54.3, the exercises, we'll start problem number 1, and they want me to factor it. Now, certainly, if I were factoring the problem, I think I would just go for trial and error on it. And the reason for that, it looks fairly simple. It's x and x, and that's if it's with integers, it's simple. 33, 3 and 11, it looks fairly simple. Right, and that does factor that way. However, really what they're asking you to do is learn something new, so they want you to use the quadratic formula to get the roots. All right, so I'll do that. And so x would equal, and let's write this down. So it's going to be, let's see, and again, it's more difficult. There's no doubt about it. Let's see, x would be equal to the opposite of b, which is minus 14, plus or minus 14 squared minus 4 times a. Well, a is 1, so 4 times c, which is 33, over twice a, which is 2. What do you get over here? Again, I want you to make sure you appreciate this is really easy to do. I'm using something different, though. I'm using quadratic formula to find the roots, then I'll use the roots to find the factorization. So minus 14. I got to do 14 squared, right? So that's 14 times 14. That's 140, because 10 times 14 is 140. Then you get 40 and 16. That's going to give you 196. 4 times 33 is 120, 132. I'll do the subtraction. This is side work. That's going to be 6. And you get 64. So plus or minus, the square root is 64 over 2. And I can continue with that. What do you get? X equals minus 14 plus or minus 8 over 2. Well, this reduces to minus 7 plus or minus 4. And what would you get there? X would be equal to minus 7 plus 4, which is minus 3, or the other one would be x equals minus 11. And if these are the roots, then the factors must be x plus 3, x plus 11. Now, granted, that might seem like a ridiculous way to get it, but it's something you want to learn, all right, because it's going to help us when we can't factor using our fingers. We'll still be able to factor the problem using quadratic formula. But again, we start basic, and we'll move to more advanced problems. All right? Thank you.